Hi everyone. Today we're going to study Laplace transforms of piecewise functions. Let f of t be a piecewise function. Then Laplace of the function f of t is equal to the formula, which is the definite integral from 0 to infinity of the function e raised to negative st times the function f of t, then dt. But in this case, for the piecewise functions, we're going to evaluate and add the definite integrals for each of the functions of the piecewise function with respect to defined limits. Example 1. Find the Laplace transform of f of t equals sin t when t is between 0 to pi and 0 when t is greater than pi. We write the formula for the Laplace transform with respect to the definite integral, and in our f of t here we have two functions. Since the second function is 0, we will only write and evaluate the sin t function, which means we're going to evaluate the definite integral of this e raised to negative st times sin t dt with respect to the limits from 0 to pi. And in here, we're going to evaluate this using integration by parts. I hope you still remember the process. I'm going to put the link of integration by parts video in the description below. Solving this by integration by parts, we have now this answer. Sin t times the quantity e raised to negative st all over negative s minus the integral of e raised to negative st all over negative s times cosine t dt. By putting the constant outside and combine this negative sign with the negative s, so it becomes like this. It becomes plus 1 of s times the integral of e raised to negative st times cosine t dt. In this case, for this integral, we're going to use another integration by parts. By doing so, the new equation becomes like this. We simplify further by multiplying the 1 over s to each of the terms inside the grouping symbol. So, it is simplified into this line. At this point, take note that we have this integral of e raised to negative st times sin t dt, which is same with our left side value, the integral that we want. What we're going to do here is to transpose this integral to the left side. This is negative, so it becomes positive to the right. And then we take the integral as the common factor. The new line becomes like this. The integral is now multiplied by 1 plus 1 over s squared. At this point, let us combine this 1 plus 1 over s squared into one fraction. So we have s squared plus 1 all over s squared. The next step, we want the integral to be alone on the left side. Let us multiply this equation by the reciprocal of this fraction, which means let us multiply the equation by s squared over s squared plus 1. The left side becomes integral alone, and the s squared over s squared plus 1 now becomes a factor on the right side. Then we multiply this fraction to all the terms inside the grouping symbol. Then we have like this. At this point, let us factor out the GCF of the fractions. So we have now e raised to negative st all over s squared plus 1 that is multiplied by negative s sin t minus cosine t. At this point, let us evaluate this with respect to 0 to pi. So we have here the two groups. The first group is this function evaluated with respect to pi, minus the second group is this function evaluated with respect to 0. Then let us simplify some terms. On the first group, let us copy this fraction, and this sine pi is simply 0, that when we multiply it by negative s, it becomes 0, minus the cosine pi is negative 1, minus, for the second group, this e raised to negative s times 0 is simply 1 all over the denominator s squared plus 1. Sine 0 here is 0, multiplied by negative s is 0, minus cosine 0 is 1. When we simplify further, we can see that we have this e raised to negative s pi plus 1 all over s squared plus 1. This is the final answer. Example 2. Find the Laplace transform of f of t is equal to e raised to 2t when t is between 0 and 3, and the function 1 when t is greater than 3. We write the formula for Laplace transform, and then let us evaluate the corresponding functions. So we write here the definite integral from 0 to 3 of e raised to negative st for the function e raised to 2t then dt, plus for the second function, the integral from 3 to infinity of e raised to negative st times the function 1 then dt. For the first integral, we can see that this is e raised to negative st times e raised to 2t, where we can combine together as e raised to negative st plus 2t. We can factor out common terms in the exponential. So we have this negative of s minus 2 times the t. We are now ready to take the integral of each of these. For the first integral, it becomes e raised to the negative of s minus 2 times t all over the negative of the quantity s minus 2, plus the second integral becomes e raised to negative st all over negative s. For the first integral, we will evaluate from 0 to 3. For the second integral, we will evaluate from 3 up to infinity. For the first integral, it becomes like this. The first fraction here is the evaluation of this function with respect to 3, minus the second fraction is the evaluation of this function with respect to 0. Then plus the second group becomes like this. We evaluate this function with respect to infinity, minus we evaluate this function with respect to 3. Then let us simplify further. For the first group here, we'll just simply copy and simplify some terms in the exponent of e. For the second group, in the exponent, we simply write e raised to 0 all over the s minus 2. Take note that the negative and negative becomes positive. Plus, this third group here means we can simplify this e raised to negative s times infinity. We multiply infinity by negative s, it becomes negative infinity. And we rationalize the exponential with negative infinity by putting it in the denominator. So we have here 1 all over the negative s times e raised to infinity. Then for the fourth fraction, we combine this negative and the negative sign of s into positive. Then we just simply copy this e raised to negative 3s all over s. Simplifying further, take note that this 1 all over the negative s times e raised to infinity is simply equal to 0. And this e raised to 0 will be 1. Writing again the problem, it becomes e raised to negative 3 times the quantity s minus 2 all over the negative of s minus 2 plus 1 over s minus 2. plus e raised to negative 3s all over s. This is the final answer. I hope you learned something from this video. See you again next time.